Hello and welcome to Damp Sam's Damp School. Today I'm going to show you how rising damp works in its simplest form. So just to explain about rising damp. Rising damp occurs when water from the ground it dissolves salts, nitrates and chlorides, and that ends up in a liquid form. So you've got a source of moisture underneath, and we imagine this is a brick, and then you've got at the side of it, at top, at bottom, you've got a mortar course. Now the mortar and the bricks both have what's called capillaries. So the small little pathways and holes that make the brick porous. Now some bricks are denser than others. Engineering bricks really dense, and you've got your cheaper ones that are not so dense. But the bricks are always more dense than the mortar. Or a lot of times they are. So the groundwater is sat at the bottom, so you imagine the brick sat in water, and that water travels up through what's called the capillaries, and they're little tubes and pathways, and they can be long and narrow, and it all depends on how long and how narrow they are for how far the water will travel up the wall, the moisture will travel up the capillary. Now if it's got a damp proof course, a physical one that sits on top, in theory this stops any groundwater from travelling up. And this is what I'm going to show you today, a really simple way of explaining how a damp course stops groundwater from travelling up the wall. And just as a caveat, I'll just explain is, because this water is laden with salt, is saturated with salt from the ground, which is dissolved in it. When it travels up through the capillaries, up the wall, it'll get to a certain point when it'll start to evaporate out of the wall. So it's kind of top of the tube. And when that evaporates out at wall, so it travels up, then evaporates out, and it goes as a gas, as water vapour through the fabric, so that comes out through your plaster. The salts, as it evaporates, the salts are left behind as a deposit on the front of the plaster or masonry. And this is normally it's normally one of the first experiments that people do at school. One at first that I did. So you got a beaker, you filled it with salt, you put it on a stand with a Bunsen burner underneath it, and you left it until all the water evaporated, and then you saw that there was salt on inside. And that when they say you're never going to use out at school, and this is going to be no good to me at school. How wrong could I have been? So this experiment is going to be like this. Or just to add, water always finds its easiest route. So if the brick is denser than the mortar, it's going to travel up mortar, and that's why we know that that rising damp will travel through pathways for mortar. So that's why we drill and inject each perpendicular of the mortar. So what I've done here, we've got what's called the Great Wall of Damp Sam. So imagine this on a massive scale, and it's built from these bricks, which are sugar cubes, and these are a prime example of a brick with a lot of capillaries in it. So I spent most of this morning building this wall, trying to get it straight. And I've cut this is a plastic, it's a ruler, it's one of Delta's rulers actually, but and I've cut it up, so sorry everybody at Delta, but must and all that. So this is going to sit as a physical damp course does when bricklayers are starting and putting damp course, they roll out a plastic damp course. This is plastic. So I've sat my damp course on top of that first course of bricks. So now I'm gonna fill this wall up, so you'll have to bear with me because I'm rubbish at editing, so I can't fast forward it, but I'll do it as quick as I can. So I'm laying these bricks on Damp Sam's Great Wall of Damp Sam. So we've got one more course to go. And I did bricklaying at Barnsley College. 2 years I did. You can tell, can't you? So I just need to straighten it up. Oh my god, clumsy fingers. That's without drilling and injecting. So there you go. The Great Wall of Damp Sam. Now what I've got here is, this is going to represent the moisture in the ground, the source of moisture. So you've got underneath the footings and everything, you've got all water, and some areas are wetter than others. So what we're going to do is we're going to pour this water into the bottom, and you'll be able to see what happens if I turn it. I'm just looking now, you can't, you need to be this way, don't it? So you can see the two courses. Right. I'm going to try and do this without splashing, because I don't want to get any odd thing, so. And as you can see, I spilled some on top. So, can you see what's happening on the right? The water's shooting up the capillaries. Oh my god. So that's just collapsed and pushed water onto over damp proof course. And that's what you call bridging. So where they fell and landed against that wall, it's now bridged. And I think, there you go. When I saw this done originally, it worked brilliant for bloke. So my 2 years at Barnsley College have not learnt me much. But I hope you could see that before this wall on the right, it might be all left, collapsed, the damp proof course was stopping any water from going up. So it's just a simple experiment that's gone exactly to plan, and I hope you enjoyed it, and I hope you get the gist of what a damp proof course does inside a property, on a wall, to stop damp getting inside a property. And a retro fitted damp proof course, you drill and inject each perpendicular, so your perpendicular coming up, your perpendicular coming down, and then you inject what is a siloxane cream now, which coats the inside of the capillary, which is the tubes that go up and the water wicks up them, and it coats the inside of the capillary, and it alters the shape of what's called the meniscus, which is like a skin on top of the water. And you see if I can get this right. So it takes it from concaved, smiley face, which goes like that, skin, to convexed, which is an unhappy face. But it's an happy face to us because it stops water from wicking up the mortar. I think I'm gonna end it here because I think you'll get the gist of it, and this textbook demonstration. I've even got same colour shirt on as my salty water. So I hope you enjoyed it, that anyway, and I hope you got some value from it. And if you made it to end of the video, please subscribe and share. This because there might be some more failed experiments, but hey ho, this is how it goes into it. So I hope you're learning something anyway. So that's Damp Sam signing off. You have a brilliant week. Oh my word, is it not working?